Okay, let's start. You're hearing me well?
Yes.
Yes, okay, so let's start. Today we are going to start a new lesson, which is describe dilations. So before we took the reflection, we took the translation, rotation, all these are type of transformations. Today we are going to take another type of transformation, which is the dilations. So we're done from the others, now we are going to start the dilations. So in this lesson, we have two objectives. The first one, verify the properties of a dilation. So we are going to see what is dilation. The second one, graph the image of a dilation given a fixed center and a common scale factor. So we are going to see that dilation needs a given fixed center and a common factor. Clear?
Yes.
Now, before I tell you what's the meaning of dilation, you will see these pictures and you will tell me, what do you think about dilation? What do you think? What is dilation?
The same shape but smaller.
Okay, we can say same shape but smaller. What else? What else?
Maybe sometimes smaller and sometimes bigger.
Very good. Sometimes smaller and sometimes bigger. Who's this?
Mariam Sana.
Yes. Very good, ya Mariam. What else? So from these photos, Mariam and Shok, they told me that dilation, maybe after we dilate, for example, a triangle, we will have a smaller triangle, maybe we will have bigger triangle. Very good. What do you think about, for example, angles, about sides, about shapes, about size? What do you think?
Different shape but the same size and double them.
Different shape?
You double them.
For example, if I have a triangle and I dilate it, I'm going to have a rectangle.
The same.
No,
I
I
mean
mean
different size, but
So same
different
shape,
size.
same shape. Very good. What about the size? Yes, Yahya.
Different.
Different size. Very good. Okay, what about the angles? Let's say the angles.
The same.
the same.
The same angles. Very good. Same angles. Very. So can you tell me what's the difference between the dilations and the other transformations that we took them before?
Transformation have to be the same size and the same that shape.
Yes, yeah,
But
Mariam. Very good.
will be the same shape but different size.
Excellent, yeah, Mariam. So clear till now, what is dilation? What we are going to do after we dilate a triangle, for example?
Yes.
Yes.
Okay, very good. So here, what can you say about dilation? I took your answers. So dilation. A dilation is a transformation that results in an image with the same shape, same angles, same measures, and same orientation as the pre-image, but the difference here is only what? The side length. So or we are going to have a image that is larger, or we are going to have an image that is smaller. Clear? Let's go back here. Look at the first picture. A, B, C, A prime, B prime, C prime. Do they have the same orientation? Do they have the same orientation?
Yes.
Yes, very good, yeah, Mariam. What about the rectangle MLKJ and M prime, L prime, K prime, K prime? Do they have the same
Yes.
orientation?
Yes.
Okay, and the transformations before, do we have the same do we have the same orientation? Reflections, rotations, we had the same orientation?
No.
Oh, very good. So here, the dilation is also different by that we are going to have the same orientation of the image, if the pre-image, for example, before, if I have A, I will not, and if I have, for example, here A, B, sometimes I will have this side inverted. It's going to be A, B, but in the other way. Yes? So,
Yes.
so clear what's the meaning of dilation till now?
Yes.
Yes.
Okay. So, dilation produces image that they have the same shape as the pre-image. They are going to be the same shape, the same orientation as the pre-image. So we are going to have them same orientation.
So,
Different
Miss, the only
size.
different thing is the size.
Hmm?
Size. The only different thing.
Yes, the only different thing is that the side. The size difference, it means that the side lengths are different and same angles. So dilations produces images that they have the same shape, the same angles, same orientation, different side length. Here we are comparing, means that we are comparing the image and the pre-image. Clear?
Clear.
Clear till now?
Yes.
Okay, let's move now to the other side. Example 1. This example are from the book, how we started usually, example 1, example 2, example 3 during the explanation. So I put here the same examples. We have here, well, what do you think? What do you have in this picture? Tell me, what can you see?
Dilation.
Okay, why did you say dilation and you didn't say rotation, for example?
Because you have a bigger
We have
bigger
two
size.
sides of squares or rectangles.
Yeah, because we don't have the same size. We have a bigger one. Very good, ya Mariam and Chol. So here, first of all, we have dilation, yes?
Yes.
Okay. The image of a dilation has the same shape. It was a rectangle, A, B, C. It's going also to be a rectangle. I cannot, for example, have a triangle and I dilate it, so I'm going to have a rectangle. No, I will have the same shape, same measures, same orientation also. If you see A, B, C, D, A prime, B prime, C prime, D prime the same way, but only different side length. What do you mean by different side length? Compare for me, which two sides here? I compare.
A.
Yes.
A prime will be with A.
What's the meaning of side? Give me example of side from the triangle, rectangle A, B, C, D.
From B till C.
So BC is a side, yes?
Yeah.
Compare this BC to the other side of the image. It's going to be what?
Bigger.
Yeah, it's going to be B prime, C prime, which is larger than BC. So here are the sides different. Clear?
Are they going to ask us to make one?
Hmm?
Are they going to ask us to make one?
Yes, they will
Like they will give us ABC
yeah,
and we will have to make
exactly. They will give us the pre-image. We are going to do the image.
How do we do it?
Yalla, miss, we will see. Just
Okay.
wait, okay? Now, when we talk about dilation, we are going to talk about a scale factor, which is R. So when we have dilation, we talk about a scale factor. The scale factor is R. Clear?
Yes.
So every time we have dilation, we have a scale factor R. What do you think?
R.
What do you think this is scale factor? How can we find? Or don't tell me exactly how can we find, but it's related to what? From where can we find it?
Multiplying.
From what?
Multiplying by multiplying.
Okay, multiplying.
By multiplying.
Okay, maybe you are going to use multiplication here. Yes, ya Fatma, but I mean, this R is related to what?
The rotation.
Dilation.
It's related to dilations, but I mean, if I need to find the value of this R, what I'm going to use? What do you think?
Are you gonna see the length?
Very good, ya Mariam. So we are going to see the side length. If it's the only thing that is different, so for sure this scale factor is related to this thing that is different. Yes?
Yes.
So to find the scale factor, I am going to use the side length of the image and of the pre-image. So this is it's the ratio of a length in the image. So if I have, for example, a length of the image, for example, A prime, B prime, to the corresponding length in the pre-image. What is the corresponding length to A prime, B prime?
Again?
A prime, B prime is the length of the image. What is the corresponding length in the pre-image to A prime, B prime?
C
B
prime.
and C.
A prime, B prime is the side of the image. So I'm going to compare it to the side of the pre-image. Which
A
side?
and B.
A and B.
A,
And
B. No, don't say A and B. The side is A, B.
A, B.
Clear? So A prime, B prime is the corresponding side for A, B. B prime, C prime is the corresponding side for B, C. D prime, C prime is the corresponding for D, C. A prime, D prime is the corresponding one for AD. So if I need to find the scale factor R, I am going to use A prime, B prime, and AB, or B prime, C prime, and BC. Not A prime, B prime, and BC. No, for each side, there is a corresponding side. Clear till now? We will see how we will find it, but clear till now?
Yes.
Okay. Also, when we are talking about dilation, we will talk about a fixed center. For dilation, we have a scale factor, which is R, and we have also a fixed center. In this lesson, we are going only to see the center, which is the origin O. So all the centers of dilation in this lesson are going to be the origin O. What do I mean by this one? If you need to make a line from O to A prime, do I find a straight line that passes through these 3 points?
yes.
So A and the image A prime and the center O are on the same line. What do you think about the other points? O, D, and D prime. Are they in the same line?
Yes.
So O is the center here. O, B, B prime are on the same line.
Yes.
So here the center is O. For example, let's take the point B prime, B, and C. Do they give us a straight line?
Yes.
B prime, B, and C.
No, no.
No. So here we cannot say that C is the origin, that C is the center, because they don't make a straight line. For example, A, D, D prime. Do they give us a straight line?
No.
So can we say that A is the center?
No.
But O, D, D prime, they give us a straight line. So we can say that O is the center of the dilation here. Clear about the center?
Yes.
Clear all about the center?
Yes.
Yes.
So when we talk about dilation, we talk about a scale factor R, and we talk about a fixed center, which is going to be in this lesson, O. Clear? And don't forget, dilation, we keep everything the same shape, same orientation, same angles. The only different thing is what?
The size.
The size. Very good. Now, we have 2 types of dilation. What do you think? What are going to be these 2 types? Please raise your hand. I want to see. What are going to be the 2 types of dilation? Yes. What are going to be the 2 types of dilation? Yes, yeah, Noura Shatti.
There can be one with O, one without O. One has a straight line and no straight line.
No. I mean here, I dilate And here I mean about the image and the pre-image. There is a relation. So we have two types of dilation. So Yanura, what are going to be those two types of dilation?
The ones that have same shape.
Dilation is
The same
always
size.
dilation is always the same shape.
I mean same size, sorry, and different size.
Enlargement
Enlargement, yes,
and reduction.
yes. So
Reduction is the small, I guess.
yes, so we have two types of dilation. We have, okay, so we have here two types of dilation. The first one, we dilate to enlarge a figure on a coordinate plane. So here, or we dilate to enlarge a figure. It means that I have a pre-image. I'm going to dilate this pre-image. So I will have an image. So in this type, the image that I will have it is going to be larger or smaller. So for the first example,
Larger.
dilate to enlarge. So the image is going to be what?
Larger.
Larger, very good. And the other type of dilation, we dilate to reduce a figure. So we dilate to reduce a figure. It means that the image that I'm going to have, it is going to be what?
It will be smaller.
Smaller, very good. So it's going to be smaller. So we have two types of dilation, or enlargement or reduction. Enlargement, it's going to give me an image that is going to be larger. Reduction is going to give me an image that is smaller. Now, example 2. This is also from your book. We dilate to enlarge a figure on a coordinate plane. So we dilate to enlarge a figure on a coordinate plane. Let's have this figure. Just look now to A, B, C, and D. Don't look to A prime, B prime, C prime, D prime. So I have a pre-image, which is A, B, C, D. Before, I told you when we have dilation, we are going to talk about two things. What are these two things that we are going to talk about them? Raise your hand. Raise your hand. So we have two things. We are going to talk about them. Yes, ya Mariam Sana. What are these two things? Yes. What are going to be these two things that we talk about them during dilation? So I have dilation. I have two things. I told you before in the slides before. Yes.
The side length.
So we have two things. We are going to talk about them. Yes, ya Mariam, again?
Noor Shat is raising her hand.
Yes, ya Noor Shati, tell me. We are going to talk about what? Yes.
She put her hand down.
So Mariam, you are going
Enlargement.
Okay, enlargement. But I told you there is two things that we are going to talk about them. The origin, and the other one is called what?
What's it?
Yeah, it's a new word, which is what? The scale.
Reduction.
The scale factor. Yes?
Okay.
Okay. So when we have dilation, we talk about scale factor and we talk about origin. The question here is, what are the coordinates of the image of A, B, C, D after a dilation? So here I have the shape A, B, C, D. I am going to dilate it. The origin is 0, 0. The scale factor here is what?
2.
2. Here the scale factor is equal to 2. So this scale factor is greater than 1 or less than 1?
Greater.
Greater than 1, yes. So what do you think? Is there a relation between the scale factor and the type of dilation?
I guess yes.
Okay, what's going to be this relation?
Maybe you'll know that if it's bigger or smaller by the number.
Very good. Also, we can know if we are going to enlarge or we are going to reduce from the scale factor? You told me now this scale factor is greater than 1. So I'm going to have a larger image or a reduced image?
Larger.
Larger image, very good. So take it a rule. A dilation with a scale factor greater than 1 is called an enlargement because the image is larger than the original figure. So you can, if the scale factor is given and this scale factor is greater than 1, so for sure the image that you are going to have it is going to be larger than the pre-image. Clear?
Yes.
So once the scale factor is greater than 1, so we will have
Miss, I mean 1 point bigger?
2, 3, 4, 4.5, 5.5. Any scale factor greater than 1 is going to be enlargement.
Miss, how do we know what point are we going to put it in?
Till now, we still have the scale factor is equal to, so here we are talking about enlargement. Clear this point?
Yes.
Yes.
Okay. Now, we are going to find the new coordinates, the coordinates of the image. How we find these coordinates? Now we will see. So we have A, B, C, D. Yes, Yashok?
Yes.
The first step here is going to be finding the coordinates of each vertex of the pre-image. What do you mean by finding the coordinates of the vertex of the pre-image? It means finding
The points.
what? Yes, the points.
The points.
Which point?
Like A, it's 2 and negative 2.
Very good, Yashok. So here, for the first step, we find the coordinates of each vertex of the pre-image, which is A, B, C, and D. So we just put the coordinates of each point. Who want to tell me the coordinates of the point? Raise your hand so I can see.
Me.
I want other than Mariam and Chog. Please, miss. Yes, Yahaya. What are the coordinates of the point A, B, C, and D? Tell me.
Coordinate A is 2, negative 2.
Yes, and B?
B is 2, 1.
2, 1. Very good. So A is 2, negative 2. B is 2, 1. Yes, ya Dana Al-Hatim. C and D. Yes, ya Dana. C
Yes,
and D.
C, 4 and O.
4 and 0. Yes. And D?
D, 4 and 1. Negative 1.
Very good. 4, negative 1. So this is the first step. We find the coordinates of A, B, C, and D. What we are doing here is we are going to find the coordinates of A prime, B prime, C prime, D prime. We don't have this one. We are going to find them. Clear? Clear what I am doing in this slide? Okay, so this is the first step. The coming step, I need to dilate to find the coordinates of the vertices of A prime, B prime, C prime, D prime. So I need to find the coordinates of A prime, B prime, C prime, D prime. What I will use here is the scale factor. What is the scale factor here? Is equal to what?
2.
2. So I am going to use this scale factor to find A prime, B prime, C prime, D prime. What is the way?
Do we add them?
No,
Add them.
we multiply them.
We are.
We multiply. So multiply the coordinates of the pre-image by the scale factor. What do I mean by this sentence? Multiply the coordinates of the pre-image by the scale factor. So I multiply what by what?
You multiply for
2
example,
by
A,
the
2
number.
negative 2 times 2.
Very good. So I'm going to multiply the x and the y by the scale factor. So I multiply x by 2 and y by 2. In this case, when I multiply by the coordinates of A, I'm going to have the coordinates of which point? If I
Of
multiply
A prime.
A prime, very good. And the same for the points B, C, and D. So first step, we find the coordinates of A, B, C, and D. After this, we check the scale factor that we have is equal to 2. So we multiply this scale factor by the x coordinate, and we multiply the scale factor by the y coordinate. Clear?
Yes.
Okay. Now, I have the point A, 2, -2. Who will find for me the points A prime? Yalla, raise your hand. Who will find for me A prime? Mariam Sana?
Yes.
Yes. A is 2, -2. How can I find A prime?
We'll multiply it by 2.
Yes.
2 by 2.
2 by 2 is going to be what?
-4. 4, 4.
4. And the other one?
-4.
Very good, yeah, Maria. So I multiply 2 times 2 and -2 times 2. 2 times 2 is going to give me 4, and negative times positive is negative, so it's going to give me -4. Clear?
Yes.
Miss, it doesn't
Yes.
have to be 2, right?
No,
It
sometimes it
just
can be
it
3.
depends on the scale.
Yeah, this is the given of the
Factor.
question. The scale factor is equal to 2,
Okay.
so we follow the given. Who will find now for me for the point B? Yalla, raise your hand. For the point B. Yes, Yajud. So the point B is 2, 1. How I find B prime?
Multiply by 2,
Yes, so it's going to be what?
4 and 2.
Very good. So B prime is going to be 4 and 2. I just do 2 times the scale factor. So 2 times 2 equal 4. 1 times the scale factor means 1 times 2 equal 2. For the point C, who will find for me the coordinates of the point C prime? For the point C prime, who will find for me the coordinates? Other, I want new girls. Yes. No new girls. Yes, yeah, Mariam al-Maktuf. C prime are going to be what? Yes, yeah, 8 and
0.
0. Very good. So we just multiply 4 times 2 equal 8. 0 times 2 equals C prime, equals 0. So this is the coordinate of C prime. For the last point now, D, 4 and -1. D, 4, -1. Yes, Yashog. What are going to be the coordinates of D prime?
It's going to be 8 and -4. -2,
8 and -2. Very
2.
good. Okay, what do you think now? What's going to be the coming step? We find A prime, B prime, C prime, D prime. What to do now?
Plot them.
We plot them. Excellent. So the step 3 is going to be graph A prime, B prime, C prime, D prime. So we plot each point. We have the coordinates. We plot each point A prime, B prime, C prime, D prime. In this case, the image that we have it is larger than A, B, C, D. So is it right that it's going to be larger?
Yes,
Why?
because it will be bigger.
Yeah, but who tell us from the beginning that it's going to be larger?
The factor.
The scale factor. Very good. The scale factor is 2. I told you when the scale factor is what?
Greater than 1.
Greater than 1. So with the image that we are going to have, it will be
Bigger.
larger.
Enlarged.
Excellent. Very
Miss,
good.
if it is 1,
We will see. We will see. Just wait. Clear? Clear till now?
yes,
Okay, let's move.
yes.
Here we have application. Who wants to solve this application?
Me.
Who is this? No new girls as usual. Yalla, choose one. You choose. Who wants to do this one?
Let me see, you have to choose.
Okay, I will choose. Yes, ya Noor al-Shatti. Read and tell me what we are going to do.
Draw the image of triangle DEF after a dilation with center 0, 0 and scale factor of 2.
Yeah, so what do you think here? The scale factor is equal to, so the image that we are going to have, it is going to be what?
Multiplied by 2.
Yeah, but the image is going to be?
Dilation.
The image is going to be larger or smaller? Larger, very good. So the first step, we said that the first step is going to be what?
Plot the coordinates.
Find the coordinates of D, E, F. Start. What are the coordinates of the point D?
D equals 0, 0.
0, 0, very good. E?
E equals 0, 2.
Coordinates
2
of
zeros.
2, 0, very good. F?
F 0, 2.
0, 2, excellent. Now, if we want to find D prime, E prime, F prime, we are going to what to do?
Multiply them by 2.
Multiply them by 2, very good. So we multiply each coordinates by 2. So now find the new coordinates. What are the coordinates of the point D prime?
0, 0.
0, 0, yes. Next,
E is going to be 4, 0.
E prime is going to be 4, 0, and F prime?
0, 2, 0, 4.
0, 4, very good. Now the coming step is going to be what?
Graph the image.
Yalla, can you plot the points, Yanura?
Yeah.
Yalla, plot.
D is going to be 0, 0.
Okay, 0, 0, where is going to be?
I don't have the pen with me.
Oh, okay, I will make it just wait. Yes, Yanura, start.
Okay, so D
0, 0, very good. So this is, the point is going to be 0, 0. What about E prime? Very good. And what about F prime? Very good. And then what we do, we match them together. So now we have the new triangle, which is D prime, E prime, F prime. Is it larger?
Yes.
So we are right now? Our solving is right?
Yes.
Yes. Very good, Yanura.
Yes.
Hear this example, girls? Clear this example?
Yes.
Okay.
Yes.
Yes.
Let's continue now. Example 3. We dilate to reduce a figure. So now we are going to dilate to reduce the figure. What are the coordinates of the image of PQRS if here the dilation for this is with the center 0, 0 as usual and a scale factor which is 1/2. The scale factor 1/2 is what?
Half. 0.5.
0.5. Is 0.5 less than 1 or greater than 1?
It's less than 1, so it will be
Less
smaller.
than 1. So it will
Less
be
than-
reduced.
So here the image is going to be
Smaller.
reduced. Yes. Just wait. Okay, so here we have the scale factor which is 1/2. 1/2, it means 0.5. So here it's less than 1. So we're going to have a reduced image. But be careful for one thing here. For example, if I have, let's say that I have the scale factor -1. Is -1 less than 1?
Yes.
But what I'm going to have, can the scale factor be negative?
No.
No, I guess best was positive.
Yeah. So when the scale factor is between 0 and 1, I'm going to have a reduced image. So the scale factor, it can't be negative. Clear?
Yes.
Yes.
So a
This I
dilation,
said clear.
a dilation with a scale factor between 0 and 1 is called a reduction because the image is smaller than the original image. Clear? Here the scale factor that we have it is 1/2. 1/2 is less than 1. So we are going to have an image that is reduced. Let's continue now. We have the square PQRS. We are going to dilate this square.
Wait, Miss.
Yes.
Miss, how's it a half?
Scale factor is 1/2, which is 0.5. Between 0 and 1. Yes? 0.5 is between 0 and 1.
Oh, so we're going to make it smaller. Okay.
Yes. Clear? So when it's between 0 and 1, it can be 0.2, 0.3, 0.4, 0.9, 0.8. As a fraction, 8/9, 2/5, 3/2, 5/6. These are all 0 point. So between 0 and 1, so we are going to have a reduced image. So we have here the coordinates of P, Q, R, S. We need to find P prime, Q prime, R prime, S prime. So what is going to be the first step?
We multiply it by 2 or what?
What we will multiply by 1/2. Before we multiply, what we have to do?
First, find the coordinates.
Very good. So first we need to find the coordinates. Yes, Yahya, find for me the coordinates of P, Q.
6, 9.
Yes, and Q?
10, 9.
So the first step, identify the coordinate. 10, 10. And 6, 10. Clear? The y coordinate here is 10, not 9, because 8, 9, 10. Okay?
Okay.
Yes. Now, what about the coordinate? RS. Who wants to find the coordinate of RS?
Yalla, I want to answer. I don't answer today.
Okay.
Yes, yeah, Mariam. R
R and S.
R and S. Tell me the coordinates.
R is 10 and 6.
R 10 and 6.
And S is 6 and 6.
So R 10 and 6, S 6 and 6. The counting step is going to be what?
To multiply by half.
Multiply by 1/2. So we multiply each coordinate by 1/2. This is the second step. So dilate to find the coordinates of the vertices of P prime, Q prime, R prime, S prime. So we are going to multiply the coordinates of the pre-image by the scale factor. We have the first point, P, 6, 10. Who wants to find P prime? Yes, ya Mariam Sana, P prime.
We multiply 6 by half.
Yes, so we multiply 6 by 1/2. If we multiply two fractions together, here 6 is like 6/1. It's going to be what? Yes?
3.
3, very good. And what about the y?
Wait. 5.
5, very good, ya Mariam. Why? I will explain for you why. Because here 6, it's like 6/1. So we multiply numerator by numerator, denominator by denominator, yes?
Yes.
So it's going to be 6 times 1, 6. 1 times 2, 2. So 6/2 equal 3. Please, miss, if you have a question for this one, tell me. I will explain it more clearly.
Miss?
Yes.
Miss, do it again.
Okay, I will make it again. If we have 6.
Miss, I have a question. Wait.
Yes.
Miss, if we did 0.5 time multiply by 6,
You will have 3. You will have 3, yes.
Why don't we do 0.5 multiply by 6? It will be easier.
You can do the way that you want it. See, it's like 6/1 times 1/2. So we multiply 6 times 1.
6.
6.
6 over 2.
2 times 1, 2. 6 over 2 equal what?
2. 3.
3. That's it.
Oh, okay.
The same for this one. 10 over 1 times 1 over 2.
10 over 2.
10 over 2, which is what?
5.
5. Very good. Thank you, Mariam.
okay.
Now the next coordinate, Q, 10, 10. So what is going to be Q prime? Yes, Yashog.
Yes. It's going to be 5, 5.
5, 5. Very good. Yes, now R is 10, 6. Let me see who's raising the hand. Yes, Yadana Al-Hatim. R is 10, 6. So what is going to be R prime?
5, 3.
Very good. 5, 3. Now for the last point, S is 6, 6. So S prime is going to be, yes, Yahaya?
3, 3.
3, 3. Excellent. So these are the coordinates P prime, Q prime, R prime, S prime. Clear how we found them?
Yes.
So it's easy to find P prime, Q prime, R prime, S prime. Yes, Yashor?
Yes.
So once we have the scale factor, we can find the coordinates of the image. So the last step will be plotting the points P prime, Q prime, R prime, S prime. We plot them. Is it larger or smaller?
Smaller.
Why here is smaller?
Smaller.
Why it's smaller?
Because it's
less than 1.
the
Less
scale
than
factor
1.
is less than 1.
Yes, because the scale factor is less than 1. Very good. Now I just want to ask some question to check your understanding. Dilation produces similar figure, yes or no?
Yes.
Yes. Why?
Because they're the same shape but different size.
Yeah, very good, because it's going to be same shape. So yes. Dilation produces congruent figure, raise your hand. Dilation produces congruent figures.
I'm raising.
Yes, Yanura.
Me too. Yes.
Yes. Well, okay. Before you answer this question, what's the meaning of congruent figures?
Same. No, it doesn't have but same distance between the.
Yeah, very good. Congruent means same size, but here after dilation we will have.
No, it doesn't.
So no. So it's similar figure, yes. Triangle, it will give me triangle. Rectangle, it will give me rectangle. But it will not give me the same side. So that's why it's not congruent figure. Yes?
Yes.
Yes.
So dilation produces figures that have.
Can I answer?
Yes, yeah, Mariam?
The same shape
Same
but
shape
different size.
and
Different size.
different size. Very good. Now, if the scale factor, Yashog, is between 0 and 1, so the dilation is an.
What, miss?
If the scale factor is between 0 and 1,
You make it smaller. You make it
so
smaller.
it's a reduction. So it's a
Yeah, reduction.
reduction. Yes, ya Mariam Sana, the last one.
Enlargement.
Enlargement, very good. So if the scale factor is greater than 1, so it's going to be enlargement. Clearness?
Yes.
Yes.
Hear the lesson?
Yes.
Is it hard or easy?
Yes, it's easy. Easy.
Here is the key concept of the lesson, the same that we took it. When the scale factor is greater than 1, so it's an enlargement. When the scale factor is between 0 and 1, it's a reduction. Orientations, angles, shapes, they are going to be the same. The only one thing is different side length. Clear?
Yes.
Okay, now go to your
Yes.
Google Classroom Check the video assigned from ED Puzzle. It will give you more information about dilation. Answer the question as usual. And I assigned for you also one quiz. Solve it, please.
Miss, I thought the quiz was for the last lesson and
Yes, I did it.
Yeah, I saw it.
All right.
Okay. You're
I am the
taking care, Miss.
best, Hada.
Bye, Miss.
Thank you.
Bye.
Thank you. Bye.
Thank you.
Bye.
Thank
Bye.
you.
Bye.
Bye.
Bye.